Welcome to Chapter 13 of And So Squircle. In this video, we'll be very quickly finding the derivatives for our inverse base p trig functions. Let's start with arcsine base p, which is defined with arctangent, an integral we solved using a base p trig sub in Chapter 9. We'll take the partial derivative with respect to x on both sides. Using repeated chain rules, we'll eventually get to this monstrosity. We'll simplify the left fraction by multiplying by the 1 minus the absolute value of x to the p to the 2 over p, and do general simplifications of the right fraction. Now we can cancel the numerator and denominator of these fractions, leaving us with this expression. We'll get to our final form by factoring out the 1 minus x to the p to the 1 over p minus 1. Since the bit on the right is just 1, we can cancel it out, leaving us with this expression for the derivative of arcsine base p. We'll find the other three derivatives using some identities and the chain rule. First, since we have the relationship that arcsine base p plus arccos base p equals pi over 2, we can define arccosine base p like this, as pi over 2 minus arcsine base p. Then it would follow that its derivative is just the negative of arcsine base p's derivative. For arccosecant, we can choose this relationship between it and arcsine base p and apply the chain rule. We can multiply in that x squared and make the numerator look nicer before wiggling that final x squared under the pth root squared. And finally, arcsecant's derivative is found with the same pi over 2 identity. It is the negative of arccosecant's derivative. And there we have it. Told you this would be quick. Back to casual Squircle trigonometry, and here are the inverse base p trig derivatives. Okay, bye.